Hey there, space enthusiasts! Get ready to blast off into the cosmos with us. Welcome to Spaceverse, where the universe is our playground and curiosity knows no bounds. Join us on an interstellar adventure as we dive into the depths of space, uncovering its mysteries and marvels. From the secrets of black holes to the landscapes of alien worlds, we're here to ignite your imagination and expand your cosmic horizons. With mind-blowing visuals, expert insights, and the thrill of exploration, Spaceverse is your ticket to the ultimate cosmic journey. So strap in, hit that subscribe button, and let's embark on an epic voyage together into the vast unknown of Spaceverse. They suggested that Oumuamua might be a comet, but the absence of a cometary tail posed a challenge. It's like searching for a duck and not finding one, you know? So the question arises, what could it be? On the evening of October 24, 2017, astronomer David Farnokia from NASA's Jet Propulsion Laboratory was urgently composing an email to a colleague at the University of California. The email discussed a new celestial object with an incredibly unusual trajectory, unlike anything observed before by telescopes or observatories. Surprisingly, it wasn't NASA that first spotted it, but Robert Warwick, a postdoctoral researcher at the University of Hawaii. While surveying the skies with the Pan-STARRS telescope on Maui, Warwick noticed this enigmatic object. What intrigued Warwick was the object's tremendous speed, preventing the sun from capturing it in orbit. Instead of following a typical closed ellipse, its path was open-ended, signifying that it would never loop back. Warwick's prompt alert to the scientific community proved invaluable. Word spread rapidly, capturing NASA's attention. Farnokia in his email remarked, "More data is needed, but the orbit seems hyperbolic." Shortly after, they received instructions to observe the object with the Nordic Optical Telescope in Spain. Unbeknownst to them, numerous other observatories worldwide were already scrambling to catch sight of it, as its abnormal velocity hinted at an interstellar origin. Thus, it was christened Oumuamua, meaning a messenger from afar, arriving first in Hawaiian. As scientists delved deeper into their investigation, their initial surprise transformed into profound bewilderment. Almost every aspect of Oumuamua, from its peculiar shape and dimensions to its lack of typical comet characteristics, defied our conventional understanding. It became evident that if this object represented a typical visitor from the cosmos, our knowledge needed a significant overhaul. Consequently, astronomers embarked on a quest to decipher its origins and the journey it must have undertaken. Initial observations hinted that it originated from the vicinity of the bright star Vega, albeit accounting for the fact that Vega's position would have shifted over the approximately 300,000 years since Oumuamua passed through. Thus, the enigma deepened, sparking a heated debate within the scientific community. While some leaned towards classifying it as a comet, subsequent observations from the Nordic Optical Telescope and other observatories revealed the absence of the expected tail and coma of sublimated dust and ice, characteristics synonymous with comets. Instead, Oumuamua exhibited a direct transition from solid to gas, challenging the comet hypothesis. Conversely, others posited that it resembled an asteroid due to its rocky appearance, except for its unique interstellar trajectory. However, the lack of evidence for sublimating ice, particularly considering its journey through frigid interstellar space, contradicted this notion. Hence, the question persisted, what precisely was Oumuamua? As the mystery unfolded, further unexpected revelations emerged. Calculations suggested Oumuamua boasted a diameter of roughly 100 meters, relatively small compared to most known asteroids, and displayed a cigar-like shape. Its proportions bore a striking resemblance to a large rocket, such as the Saturn V, measuring approximately 110 meters by 10 meters. However, its extreme orbit ruled out the possibility of it being a relic from the 1960s space exploration era. Could it potentially be an artifact of an extraterrestrial civilization? Despite the incredulity of such a proposition, scientists found themselves unable to dismiss the notion outright given the available data. While astronomers grappled with the enigma surrounding Oumuamua, another astonishing revelation emerged. In June 2018, Italian astronomer Marco Micheli of the European Space Agency, along with his colleagues, reported measurements of Oumuamua's orbit shape, uncovering the influence of a faint rocket-like force acting on the object, in addition to the gravitational pull of the Sun and planets. Yes, you heard it correctly. The object appeared to undergo a sudden acceleration akin to that of a spacecraft. The perplexity lay in the fact that it exhibited an additional push away from the Sun, a phenomenon typically associated with the rocket effect generated by the formation of a cometary tail, which propels the object in the opposite direction, much like a jet plane. However, Oumuamua displayed no such cometary tail. So, what accounted for this extra thrust? Furthermore, Oumuamua lacked the characteristic signs of mass loss typically observed in comets, which could have explained the observed force. So, what triggered this abrupt momentum gain? The situation took on an eerie hue when it became apparent that the object was departing our solar system at a velocity faster than its initial arrival. It seemed Oumuamua had little fondness for our celestial neighborhood. In November 2018, Avi Loeb from the Center for Astrophysics at Harvard proposed a daring hypothesis: Oumuamua might be a light sail, a flat, sail-shaped vehicle propelled through space by the pressure of starlight. This non-gravitational force could be attributed to sunlight, which exerts a gentle pressure on any object in its path. Oumuamua's brightness fluctuated by a factor of 10 or more, indicating an extreme geometry akin to a razor-thin piece of paper tumbling in the wind, rotating approximately every 8 hours. The Space Telescope scrutinized the space behind Oumuamua extensively, searching for traces of dust or gas, but found none. Instead, the object itself appeared to be propelled by sunlight reflecting off its surface, providing a tantalizing explanation for its mysterious behavior. Despite the captivating notion proposed by Avi Loeb, the majority of astronomers lean towards a natural explanation for Oumuamua. In February 2019, calculations revealed that for sunlight to propel Oumuamua, it would need to be 100 times less dense than air, a proposition that stretches the bounds of plausibility. The sheer peculiarity of the object left astronomers eagerly anticipating the discovery of another interstellar traveler. Their hopes were fulfilled 2 years later with the arrival of Borisov, the second interstellar object. However, Borisov presented a stark contrast to Oumuamua. While its orbit was even more extreme, resembling that of a typical comet, measurements from the Hubble Space Telescope indicated a larger nucleus ranging from 0.2 to 0.5 kilometers in radius. Unlike Oumuamua, Borisov exhibited no extreme light variations, and its non-gravitational motion stemmed from asymmetric outgassing, akin to solar system comets. These stark differences between Borisov and Oumuamua will only serve to heighten the mystery surrounding the latter, casting doubt on any assumption of a shared origin. Nonetheless, Avi Loeb remains steadfast in his belief that Oumuamua could be a spacecraft sent by an intelligent extraterrestrial civilization. His rationale stems from the object's fleeting passage near Earth, its rapid speed surpassing any human-made rocket. Furthermore, its trajectory originating from outside our solar system suggests it was merely passing through, never to return. While this speculation raises intriguing possibilities, the object's sudden acceleration without a cometary tail continues to elude a satisfactory explanation. The departure of Oumuamua marks the closing of a chapter in its enigmatic journey through our solar system. As it ventures toward the outer reaches, it leaves behind a trail of unanswered questions and speculative theories. Whether it's merely a celestial rock or an artifact of extraterrestrial intelligence remains a subject of debate and intrigue. While some may lean towards a natural explanation, others find themselves drawn to the tantalizing prospect of an alien spacecraft. As we await further discoveries and the potential emergence of similarly mysterious objects, Oumuamua will undoubtedly remain a captivating conundrum in the annals of astronomical history. What are your thoughts on the matter? Do you believe Oumuamua is a product of cosmic happenstance or a harbinger of extraterrestrial contact? Share your perspective and join the discussion. And remember to stay updated with Territory for more captivating insights into the mysteries of our universe. And that's it. Thanks for joining us on Spaceverse as we journeyed through the intriguing tale of Oumuamua, the interstellar visitor that captivated astronomers worldwide. From its mysterious origins to its baffling behavior, we delved into the depths of cosmic enigma. Stay tuned for more captivating explorations of the cosmos on Spaceverse, where every mystery unlocks a new chapter in our understanding of the universe.